So, good morning, everybody. My talk today is about service system engineering approach to maritime navigation. I want to start presenting the context of where we are now, and then move more details about maritime domain and system engineering, or more precisely, service engineering applied to navigation. We are currently, present time is currently defined as the fourth industrial revolution. As Klaus Schwab, the founder of the World Economic Forum, already in the 1913, uh, formulate the fourth industrial revolution, uh, quite different for the previous three revolutions, because this is much more a call for action, much more a systemic approach is needed, and empowering in collaborative and more sustainable approach around common shared value for the good human, good dignity, and intergeneration stewardship. That is very generic definition, and why I apply it? Because that is very much another way to see a system engineering view. Let's move on to the next view. I love very much this book, which presents some details about this fourth revolution. We may define it key elements of difference before the previous one. And the first one is the velocity. Everything is going faster and faster now. The scope, however, the impact, which is much more broad, is not confined, is not limited to production or to engineering, but it affects all society, all compartment, from industry to system to political aspect to management up to government. And also, if you want to see from the geographic point of view, the impact is not limited to some countries or some continent, but is a really global impact. What I love very much from this book is the double helica DNA schema, which combine together. If you see the two helicals, the red one and the blue one, the classic, let's say, system engineering approach could be half of this helical, while a system of thinking approach is the other half of the coin, is the other half of the helical. And we need a much more joint approach, classic system engineering, let's say in this way, with the system thinking in order to have a global overview of the context. So follow this generic approach. Let's come back a little bit more specific on the maritime domain. A very brief introduction or historical introduction. The first radar control was installed in the it was, of course, a port control system installed in the Isle of Man, 1948. And it was basically composed by a system just formed by radar and follow up some radio communication. The proposal was essentially to check, to monitor the traffic in the port, which is pretty much the basic concept that we are still in place today. At that time, looking on the system engineering approach, we were applying the classic waterfall model and the very much hierarchical model. So the waterfall comes from a static approach, requirement, design, implementation, testing, and of course, maintenance. This is in part also valid today, but with much more flexibility, much more approach, because the reality is much more complex. Therefore, let's make a little analysis of two main models. The first one is the classic V model applying system engineering. We have the first part of the V, that is the decomposition of the system, starting from user needs, going to the system requirement, system design description, software development, and then we start to integrate the various components, start to testing, start to deliver, and then maintenance. It's quite classic. However, we see that this approach is not well coupled with the speed that I mentioned at the beginning of the speed of changes, of course, that I mentioned at the beginning of the presentation. And therefore, also from system engineering, we move to different models of system engineering. There are a number of reasons to that. The first one is that statistically, the great part of the project are unfortunately failing. This doesn't mean that they not deliver their technical scope, but maybe or quite often they are delayed or they are over budget. Therefore, in terms of project, they are failing for this reason. A more agile approach has been therefore coming into effect, which is defined the Agile Manifesto, which aims to work in a more quick output, and this aims to follow the dynamic or the fast changing that often are requested by the customer or by the society or by the users, whoever they are. I'm just simplifying some concept, don't go into much details. How system engineering agile mode works. We have a core development team, which is pretty much limited in terms of capability and in terms of people, so very agile. They produce sprints and they are developing the request from the stakeholders. The core people is the product owner, which have the vision of the overall product that is then split in single sprints. And generally in this schema, you may assume you have 4 to 5 sprints per week, for example, in your capacity. And then the product owner have to assign which one prioritize and which one delay. And more important, he have also the power to say no. Say no means that some sprints, which may not really need it or may not affect the output, have to be discarded. This is very important. Again, simple representation. Key element in this approach is communication among all the team members and among all the stakeholders that are involved into the process as well. Simple speaking. What we want to do things fast, we want to do the right things, and we want to do the things right. Why these three differences? Essentially, we have the developed team, the technical part, which usually like to build the things right because approach on the technical aspect. Then we have the product owner, which means sum up here with building the right things. I mean, building what is really needed. Sometimes we have the problem that we build some beautiful system, but unfortunately it's not what the user needs or what the user requests. Maybe not because we express wrong, but because the context changed. And at the same time, we have the coach or the program manager, which want to do everything fast, respecting the milestone plan, etc. We need to move to compromise this. That is the key challenge. Moreover, situation, as I start to say at the beginning, is much more complex. Even the agile project is going to fail. Are going to fail because it's not agile enough, let's say in this way, and because the complex derived by the globalization and all the threats that we experience every day are much more growing and growing. How this global approach apply to the maritime domain? Maritime domain starts, as I say, with the first element, just a single radar. Then we move to a more hierarchical model when typically we have a radar site along the coast, then we have a local site, central site, and a national headquarter or global site. Now, this is pyramid approach. Nowadays, we have a much more flat architecture, and there is a technical reason to that. At the time where this pyramid approach was developed, there was technical limitation, for example, in the bandwidth available for data communication. And therefore, some information like video radar, for instance, remain contained in the radar site. We didn't pass up, we just synthesize the information and pass up because of the technical limitation of the connection. Now, from the technology, we have capability. I have some noise. I don't know if someone is speaking. Hello? Okay, I will continue. I hope you'll follow me.
Yes,
Sorry,
please
can everyone make
continue,
sure that their
Mikhail.
mics are off?
Mikhail, you'll need to unmute now. We've muted everybody, so if you unmute, you carry on.
Okay.
Please.
Okay. Can I continue? Can you hear me?
Yep, that's fine.
All right. So, as I say, we are moving to much more flat architecture, and because the technology allows us great capacity to transmit data among the systems. And some concept that I've already mentioned today is that we are moving to autonomous systems, and also in the maritime, we are moving to autonomous vessels and drones vessels. And the trend is what is highlighted in this simple graph. We have a level of software and automation that is growing almost exponentially. At the same time, also the interconnectivity between the system inside the ships, for instance, and the shore side are also growing at the order of magnitude less than the automation. And at the same time, the people, the number of people, the crew needed on board are going down and down because the automation is growing. It is quite obvious. In fact, if you look at some modern system, this is an example of vessel traffic services in Norway. You can see the number of screens and number of digital information that are present there. And that is, let's say, the shore side of our system. At the same time, if you go inside a modern ship, you will have something like this nowadays, which is pretty much more related to a modern video games or whatever digital application for almost everything. In fact, when we talk about modern systems, we have to talk about big data, something that is probably already mentioned today. This is an analysis conducted by some colleagues from South Korea, and it is shown here the data, the quantity of data that are produced by a single class 3E vessel navigating for 1 month. And we are talking about the magnitude of terabytes of data. This analysis shows also that optimizing the path, that means the route that the ships follow across the globe, may save up to 20 million US dollars annually only on the fuel. There is also concept of optimized path according, for instance, to weather condition or maritime condition, just to make it more clear. However, it is clear that even the maritime domain and even a single ship, it is now a complex system where we have to talk of big data approach. Again, this is picture of remote control of a vessel implemented by Navtor company. And from this center, you are able to monitor in real time the position of the entire fleet and able to transmit or somehow manage some of the component inside the ship from the shore side. At least you will receive all the information about the equipment, all the data that are collected from the ships are then analyzed on the shore side. To that reason, the International Maritime Office formulate the concept of e-navigation, which is now on the screen reported. Actually, the e-navigation is a statement which aim essentially to harmonize, exchange data information between shore and ship side and between ships and ships, ideally, by means of digital technology, by means of electronic cartography, by means of digital technology at large. The reason for that are many. Here are assumed the 5 pillars of these reasons. But essentially, what come out quite evident to the people were that if we continue to integrate the systems in a not harmonic or homogeneous way, then we come out with the risk of difficulties of, let's say, understanding each other. That means integrate each other in different contexts in the world, for example, and even more between the shore and ship side. So the very basic schema of the e-navigation architecture come out in the IALA document in our under 40, which present the shore side on the right of the screen. That is generally the vessel management system and the operators of the vessel management system. Then we have the ship side with the integrated bridge systems. So anything that is inside the ship and the connections between. As I said before, everything have to move on digital technology. So anything have to be synchronized by satellite system, simply speaking, and also has to give the right position of the object in the digital world.
Sorry to cut in there, Michael. Your time's up, so if you could wrap up very quickly, please.
All right. So I speed up and skip a little bit of the justification of this and come out to the essential of the services. We have a maritime service portfolio between the shore and the ship side, and this service is the key element of our process because the service has a number of useful information. The first one, they are not only technical service, but may include also business activities. And what I would like to highlight more, they are independent to the technology and they are independent to the number of systems that are connected to it. So when the complexity grows, the services is the key word, the key element which allow to decrease the complexity. Here is an example of data value services inside the vessel. I will not go in details for a matter of time and many other reasons, but give you just a quick peek of the overall service that are already standardized in the maritime domain. You may recognize the VHF radio communication, the radar, and the other equipment. And some other examples, technical operational service and technical services. So operational services are what the people need to do. Technical services is what supports the people to do their activity. For example, mate, search and rescue. The last slide I want to highlight, without going into details, is the overall world in the maritime domain is going to have a digital framework at the moment, and we are working hard on the IALA and IMO to standardize this. And finally, the three levels of domains that I mentioned before, because when we talk about autonomous and we talk about services as part of the autonomous, the technology may be ready, but the implementation in real world need to include all the domains that we already mentioned before in a room, because they are the human aspect that have sometimes to be overcome in order to be technology real effective in real world. And it is defined not only the producer of a service or the consumer, but the prosumer. So a new user, which is at the same time consumer and producer, like what happened when we use WhatsApp or any other transportation app. So this concludes my presentation. Thank you very much for your time, and remain available for questions.
Thank you very much, Mikel. We've got time for one very quick question. So this question comes from Ian. Did you encounter the Digital Container Shipping Association global standards for information exchange across maritime shipping supply chains when you were looking at the wider context of this work?
There are still work on it. The first or the most powerful approach in this is what is currently named the Maritime Single Window, which aims, is a global approach, which aims every country in the world need to standardize only one system, which is called a single window for this reason, where all the ships and all the information about containers, goods, whatever, are input into this system at the national level, and all the stakeholders that need to consume such information approach just one system. Currently, there are a number of variety of systems and a number of stakeholders, a number of duplication. So from the 2024, the IMO aimed to have operative the maritime national single windows in each country, which will help follow the request in the question.
Thank you so much, Mikel. Really interesting presentation, fascinating systems that you're working with there.